Hello everyone, welcome to my channel. In this video, we are going to discuss about the queue data structure. A queue is an abstract data structure which is similar to stacks, right? So in the case of the stack, all the insertions and the deletions are done at one end, right? So we can perform the insertion as well as deletion operation only at one end in the stack. But unlike in the stacks, a queue is open at both of its ends. So one end is always used to insert the data, that is the enqueue operation, and the other end is used to remove the data, that is called as the dequeue operation. But in the case of the queues, we are having two ends. So from at one end we can insert the data, and at the other end we can remove the data. Okay, so the insertion of the data into the queue is called as enqueue operation, and the removal of data is called as the dequeue operation. Okay, so that means we can insert the elements into the queue here at both the, we can insert the elements into the queue at one end, and we can remove the elements from the queue at another end. Okay, so that's why queue is called as an ordered collection of elements that has two ends named as front and rear. Okay, from front end one can remove the element from the queue. Similarly, from the rear end one can insert the element into the queue. Okay, so here we are going to know in detail about the queue from some of the real-time examples. Okay, so in this example, some people are standing in the queue. Okay, so a queue of people who are waiting for the city bus at the bus stop. So any new person joins at one end, and that end is called as the rear end. Okay, and the person who enters the bus at other end is called as the front. So he will leave the queue and he will enter the bus. That is called as the front end. So at the rear end, people join the queue, and at the front end, people will leave the queue and they will enter the bus. Okay. So this is one example. So another example is vehicles waiting at the traffic signal. So when the signal is given at one end of the junction, the vehicles will go in, they will form a queue, right? So they will start traveling in a queue. So this is also one of the real-time example of the queue. Queues are frequently used within the computer systems to hold tasks, that is the jobs, okay, in the first come first served basis. So within a computer system there may be queues of tasks waiting for the printer for access to disk storage, or even in a time sharing system. Okay, and we can even use the queues to write the event simulators. So these are some of the real-time examples of the queue. So next one is the representation of the queue. So as we have seen earlier, queue is nothing but the collection of items. So both the ends of the queues are having their own functionality. The queue is also called as FIFO, that is a first in first out data structure. So all the elements in the queue are stored in a sequential manner. As in stacks, a queue can also be implemented using arrays, linked lists, pointers, and structures. So similar to stacks, we can implement the queues in the arrays, linked lists, pointers, and structures. So in this video, we will discuss how can we implement the queues using the arrays and linked list. And we can perform certain operations on the queue, like a queue underflow, queue overflow, insertion of the element into the queue, and deletion of the element from the queue. So these are some of the operations that we can perform on the queue. Okay, so next one is the operations on a queue. So the following are the operations that we can perform on a queue data structure. Enqueue. Enqueue means insertion of an element into the queue. And dequeue, that means deletion of an element from the queue. So we can perform the enqueue operation at the rear end of the queue. Okay, only at the rear part we can insert the element into the queue. to delete the element from the queue, we have to delete it from the front part of the queue, and to display the elements of the queue. Okay, so if you want to perform the insertion operation, then the queue should not be full. That means there must be some space to insert the element. And similarly, to perform the dequeue operation, the queue should not be empty, right? If the queue is empty, that means there is no element in the queue. We cannot perform the deletion operation. Okay, so for the enqueue operation, we have to check whether there is a queue overflow or not. Similarly, for dequeue operation, we have to check whether the queue is having underflow. That means whether the queue is empty or not. Okay, so these conditions will apply for the enqueue and dequeue operation. And after performing all these operations, we can display the elements of the queue. So queue data structure can be implemented in two ways, that is using arrays and using linked list. So first we will see how can we implement the queue, that is using the array. Okay, so here we are performing the insertion of the value into the queue. Okay, so before applying the insertion and deletion operations, first of all we have to include the header files into the queue, and initially the queue will be always -1. That is the values of front and rear values will be always -1. So here void enqueue of int value. That means, so first of all we are considering the element to insert into the queue. If rear equals to size -1, so what is the size of the queue that we considered here? That is 4. So we check whether the rear is pointing to the 4 - 1, that is the last location in the queue. No, it is pointing to -1, right? So that's why this condition fails and we enter the else condition. So if front equals to -1, then make the front value as 0. Okay, so if the front equals to -1, then make the front value as 0. That means the front will point to this location, and increment the rear value here. So we are going to increment the rear value. So here the rear is pointing to the 0th location, so it will point to the next location, right? So after inserting some element to the queue, it will point to the next location. Okay, and then increment the rear value. Okay, so we are going to increment the rear value. So initially the front value will be always -1 and rear value will be 0. Sorry. Okay, so here, so the rear value is incremented. So now the front is pointing to the, so here the front is pointing to the first location, that is f equals to 0, and the rear value is 1, right? So it has incremented into the next location, and q of rear equals to value, because we have inserted some value into the queue, so it will display the value, like insertion is successful. So here this condition will meet only if the rear is at the end of the queue. That means if all the elements in the queue are filled. Okay, that is 1, 2, 3, 4, like this, all elements are filled, then we cannot perform the insertion operation here. Okay, because it undergoes overflow operation. It undergoes the overflow. Okay. So next one is the dequeue operation, that is deleting a value from the queue. The deletion of any element in the queue takes place by the front end always. Okay. So here dequeue, that means deleting the element from the queue. If front equals to rear, that means the queue is empty and deletion is not possible. Okay. So here we cannot perform the deletion operation if the queue is empty. So before performing any deletion operation, once we have to check whether the queue is empty or not. So if the queue is empty, you cannot perform the deletion operation. Okay, and the result of the illegal attempt to deletion of an element from the empty queue is called underflow condition. the queue underflow condition. So now let us take an example and we will see how can we perform the dequeue operation. See, in the enqueue operation we have inserted one value into the queue. So after running this same algorithm for 3 times, we can insert all the values into the queue and we will get this, the queue get filled like this. That means the array is pointing at the end of the queue. So if you want to delete an element from the queue, okay, so here the f is, the front is pointing to the first value in the queue. So first of all we have to check whether the queue is empty or not. Front equals to rare. So front equals to rare is not possible. So the condition fails and we will get to the else condition. So deleted %d comma queue of front. So we have deleted the value in the queue front. So front value is 1 here, right? So we have removed the value in the front and increment the front to the next item, next element in the queue. Okay, so this will get deleted logically. Okay, the number 1 gets deleted logically. That means the queue is from front to rear only, that is from the value 2 to 4. So this element is logically deleted from the queue. Okay, if the front is equals to rear, that means this condition follows, then make the front and rear value as -1. Okay, so next type of implementation is queue using the linked list. So the major problem with the queue implemented using array is it will work only for the fixed number of data. So array is a static representation of data, right? So we have to mention the fixed amount of data that we want to insert into the queues. But queue using array is not suitable when we don't know the size of data which we are going to use. So in the previous example we are taking a queue of size 4. So that means it is already defined. So I can insert only 4 elements into the queue. Okay, but if you don't know the size of the data which we are going to use, then it will be difficult, okay, to insert the elements into the queue using the array. So that's why a queue data structure can be implemented using the linked list data structure. Okay, so a queue using linked list can work for variable size of data. So that means there is no fixed amount of data for the implementation. So here the main advantage in the linked list representation is that we need not have to worry about the size of the queue. So we don't need to worry about the size of the queue. As in linked list representation, we can create as many nodes as we want, so there will not be a queueful condition at all. The queue using linked list will be very much similar to a linked list. The only difference between the two is in queue, the leftmost node is called the front and the rightmost node is called the rear node, and we cannot remove any arbitrary node from the queue. So we have to remove the front node always here. Okay, so that's the benefit of the linked list in the queue using the linked list here. So now let us see some how can we perform the enqueue and dequeue operations in the queue using the linked list. So in this manner we can perform the insertion of an element into the queue. It is the enqueue operation in the linked list. So given the linked list here, so it is in a queue format, right? So this is like a queue format. So we can insert the elements into the queue and delete the elements from the queue. So here front is pointing to the starting of the first node in the linked list and rear is pointing to the ending of the linked list. Okay, in the case of the queue using array, okay, so the overflow condition will occur, right, because the array is static storage, right? So we have to define the array is a fixed amount storage, so we have to define it before we are using. But here the overflow condition does not occur because we can insert as many elements as we want, okay, using the enqueue operation. Okay, so here at the rear end we are inserting the element. So we are inserting the new node into the array. Okay, so after inserting the new node into the in linked list, the rear will get incremented to the new node. Okay, so now let us see the algorithm here. So void insert of int value. Okay, so we are creating a new node using the structure. Okay, so first of all we are creating the new node using the structure. Okay, and using the malloc function we are allocating the memory for the new node. So new node implies pointing data equals to value. So that means new node value data is 2 and new node next equals to null. So the next one is null. Okay, so if the front value is equals to null, that means in the given queue, if the front equals to null, that means the queue is empty. Okay, so the queue using linked list is empty. Then front equals to rear equals to new node. Then what will happen? This new node, the 2 pointers will be pointing, that is the front and rear. Both these pointers will be pointing to the new node. Else, that means already some nodes are existing in the linked list. Then what will happen? Rear implies next equals to new node. So here in the given picture, so already some nodes are existing in the given queue. So then what will happen? Rear implies next equals to new node. That means so the next pointer, the rear will point to the newly inserted node here. So this will become rear pointer. Okay, rear equals to new node. So insertion is successful. So like in this manner the enqueue operation will be performed here. So now let us see the dequeue operation, that is deleting an element from the queue. So next one is deleting an element from the queue using the linked list. So here in the given queue, okay, so we are having the front pointing to the first memory location, first node in the linked list, and rear is pointing to the last node in the linked list. So to apply the deletion operation, we have to increment the front pointer to the next pointer. That means if you are going to increment the pointer to the next node, then logically the element in the first element in the linked list will get deleted, right? So here we are going to increment so we are creating a new pointer called temp pointing to the first location in the linked list. Okay, so after creating the temp, so we are going to point the front to the next location and then remove the first node in the linked list. So that we will see in this algorithm here. So here, so void delete if front equals to null, then printf queue is empty, right? So if the front is null means that means there is no element in the linked list, then front will become null. Okay, so here we are checking for the underflow condition. Okay, else struct node start temp equals to front. That means we are creating a new pointer called temp which points to the front node in the linked list. That means the first node in the linked list. Okay, so the temp will be created and pointing to the first node in the linked list. So after that we are moving the pointer of the first node to the next node. Okay, the front will point to the next node. Okay, so the front will point to the next node and then we are removing the temp here from the linked list. Okay, so the deleted element is the temp implies data, the first node in the linked list, and free of temp. So we are freeing the temp from the memory. So like this we can perform the dequeue operation using the linked list. Okay, so here we are checking for the underflow condition, but whereas in the enqueue operation we are not checking for the overflow condition. Okay, because since we are using the linked list and there is no fixed amount of data, the data is not fixed here, right? So we can insert as many elements as we want. Since the linked list is a dynamic representation, we can insert as many elements as we want. So that's why we are not checking for the overflow condition, but we are checking to remove the element, we are checking for the underflow condition. So this is about the how can we implement the queues using the arrays and linked list, and what are the basic operations that we perform on the linked list, perform on the queues. Thanks for watching my video. Please do like, share and subscribe to my channel. Thank you.